Let's start. Okay. So very first is your distance time graph. Okay. So you have already drawn the graph. So coming to graph, remember one thing. First, remember all the graph. Like how they look like this, they look like this. You have to remember this. And second, whatever today I'm teaching, just remember those things. That's it. You can do any graph thing or any question related to graph. Okay. So first, ma'am, what distance time graph. Okay. So you can see you have two graphs. One like is this, it's going upward, and the other one is going over here. Over here, our object is not moving. Right? Your object is here itself. Right? That means you are covering the distance and the object is not moving. That's why it is same. See, time, of course, time won't be, sorry, wait. Of course, time won't be changing, right? The time will be changing. For example, you are standing here. So right now it's 6 o'clock. But if you will stay here, of course, time will move. Now it is 7 o'clock, but you are still here, right? Time won't be stopping for you. So that's why time is increasing. Earlier, time was 10. Now time is 20. Now it will be 30. But distance, this is distance, right? So you are at 10 kilometer and you are here only. Whether it's 10 o'clock, 20 o'clock, whether it's 10 minutes, 20 minutes, 30 minutes, you are here. So this means that object is not moving. But here you can see with time object is moving, right? Earlier, for example, you were here, this one. Okay. Then you moved like here. Then you moved like here. So from here, you shifted to here. And from time was here, it shifted to here. So you can see here object is moving with a uniform motion. Okay. But here object is not moving. Clear? Girls, clear? No?
Yes, ma'am. Yes.
Okay. So if someone will ask you, tell me the position of the object or whether object is moving or not. So if you will get a graph like this, you can see distance is here. He covered 10 kilometer. Now he is still on 10. He is not moving at all. So that means object here, you'll just check this graph. You'll say, ma'am, object is not moving. But here, ma'am, object is moving with uniform motion. So because it is moving, you can see earlier it was, for example, I just take this, then this, then this. Okay. Now, from this graph itself, you have to find the velocity. Okay. So, ma'am, how you will find the velocity from this graph? You got the graph like this. So, whenever you are getting the graph, you have to do one thing. This is your graph. You have to make the coordinate like this. Clear? For example, it is 10, it is 20, it is 5, it is 10. Like this. So, you have to make it like this. This is your time and this is your distance. Okay. So if you have to find, I'll just give you the graph and I'll ask you to find velocity. Okay. So how, ma'am, now how you will find the velocity? So see, the first one will be your, distance is represented by S, right? So this is your S1, this is your S2, this is your T1 and this is your T2. Clear? Getting the point, girls?
Yes, ma'am.
Okay. You have to remember the formula. That is, the formula is this. Velocity equals to displacement upon time. Okay. And what is your displacement? Your displacement is S2 minus S1. Displacement is the distance somewhere, right? So S2 minus S1. And what is your time? T2 minus T1. So this is the formula to find out velocity with the help of graph. Clear? Getting it? S2 minus S1 and T2 minus T1. So you have here S2 and here this S1 and this is T2, this is T1, right? So if I'll ask you to find the answer, what you will do? Ma'am, what is your S2? It is 20 minus 10 divided by 10 minus 5. So you got 10 divided by 5. So you got 2. So what is the velocity? 2. Getting the point, girls?
Yes, ma'am.
Okay. Okay. So just a minute, I'll just erase it. So now first of all, you'll make this notes, and after that I'll give you one question to find velocity. Okay, so first of all, you will write in the fresh page graph motion. Sorry, not graph motion. Just write graphs and chapter motion. First write distance time graph, draw this and draw this. Okay, here you will draw it like this. Right here you will T1, T2, T1, T2, A, B, or S1, S2. You can write S1, S2 as well. Okay, draw this distance time graph and write here. Here write object moving in uniform motion and object is not moving. Clear? If you have this as a result, first draw this one, then draw this one. Don't because I have a space. I had space over here. That's why I've written.
Done, ma'am.
Okay. Both of you done? Adil, welcome. Okay. Adil, basically, this is very important. We are discussing graphs. So I'll just explain you one thing. You can see over here it is distance time graph. So you have two graphs, one which goes like this and one which is like this. So over here you can see this means that object is not moving. He's here. Time is moving from here to here to here, but object is not moving. But here you can see earlier the object was here when the time was this. But now object is here when the time is this. So you can see object is moving with the uniform motion. Clear? Adil?
Yes.
Okay, so you can draw it. And after this, girls, what you are going to do, like not girls, Adil also, you have to find the velocity. So ma'am, what is the formula for velocity? It is basically V equals to displacement upon time. and then you will similarly you will draw this, and there you will just, okay, you have already drawn it, okay, just draw it because you'll get a better idea. So draw it. It's like S1, S2, and over here T1, T2, and this is point A, this is point B. So this is displacement among time. And what is displacement? S2 minus S1 divided by T2 minus T1. Okay, so you'll write it like this.
finished, ma'am.
Okay. Others? Done?
Yes.
Justine done? I think Justine needed. Okay, everyone is done, I think. Okay. Then I'll just give you a question. Just write it down. Okay, I'm just drawing it over here. With the help of graph, you have to find the answers. Okay. Wait. I hope you can see my screen. Yes. Whatever I'm drawing. No.
Yes.
You have to find velocity. Okay, this is t and this is distance. Quickly find it out. Okay. Jeba, you joined late. I'll just tell you this is the question. Press 1. Okay. Don't get confused. This is the question. You have to find the velocity using the formula.
Okay, ma'am.
Done, students? Students, it's not a rocket science. Done?
Yes, done, ma'am.
The others?
Yes.
Okay. So basically, it was nothing. Over here, this is S1, this is S2, this is T1, this is T2. Simple. You just have to draw it like this. You have to make it like this and this, right? And see, 75 minus 30, 25 minus 10. So answer is 3 meter per second. Is it? Yes or no?
Yes, ma'am.
Yes.
Okay, so are you waiting for me to ask, or you were like, you were doing it? I was like, this is not a rocket science, what you people are doing. Okay. Now, earlier we were talking about the uniform thing, right? When your object will be moving in a non-uniform thing, then your shape of the graph will be like this. Just remember this. Your velocity is not constant. Okay. Now we are moving to velocity time graph. Earlier we were doing distance. Now we are going to do velocity time graph. So here, nothing. Everything is same. Okay. So it is only what's the difference is over here. For example, this is the graph. There it was T1. This is T1. T2, right? But the only difference is here it is V1 and V2, right? V1 and V2 instead of S1 and S2 you have V1 and V2, and with velocity what we find? We find acceleration, right? So there you have to find velocity, but here you have to find acceleration. And what is the formula? V2 minus this, V2 minus V1 and T2 minus T1. Clear?
Yes, ma'am.
Right? And if someone will ask you what is the distance covered, so this is the distance covered from T1 to T2. The distance is this. Okay, so you will first of all you will write non-uniform. You will draw it like this, and you will write velocity is not constant. Velocity is not constant. Quickly, be quick. Okay, because we have to do one very important thing. And after that, you are going to write this velocity time graph. You are going to draw it like this, and then you are going to write it like this: V2 minus V1, T2 minus T1. Done?
Done, ma'am.
Done.
Okay. Now the thing is that over here with the help of graph you can find out the distance. Okay, this is the distance. But in actual, if I'll ask you to find the distance, acceleration you can find it with the help of this, right? But if I'll talk to you about the distance, then what is the distance? Basically, distance between T1 and T2 is known as distance. And now what is the distance? This distance is basically the area of this. Area of this. Right? So area of okay, so sorry. So yeah, you can see the graph. Yes, and you have to find over here you have shaded it like this. Okay, so you have to find the area of this portion. Okay, so what is this portion? A, this is B, this is T1 and T2. So area of AB, T2 and T1 you have to find it like this. Clear? Right? Yes, no, maybe.
Yes.
Okay, only Adil is getting. What about others? Others not getting? Okay, only Adil is here. I think they lost the network. Okay. So yeah. So this is what I was telling about. So you have to find the area of this, right? But you have, Adil, have you seen any area like this or any shape like this? No? Yes?
Maybe.
Maybe. Okay. No. Basically, this is not a shape. You cannot say this is a rectangle. You cannot even say this is a triangle, right? So you will divide it. You will divide it into two parts. So you can see this is a triangle, right? This is the triangle and this is the rectangle. Okay. So triangle plus rectangle will make this shape, right? So you are going to add the area of, this is B, this is A. You will keep a point E. So area of a triangle ABE plus area of triangle, area of rectangle AET1 T2. Clear?
Yes.
Okay, so you'll write distance, just write this, and then over here just write it, then write area of this. It is divided into two parts. Area of triangle ABE plus area of rectangle ABT1 T2. Sorry, AE. Right? It is AE. No? So write it down. Distance. Distance travel between T1 and T2 equals to area of ABT, and this area is divided into two parts. This plus this. Okay, Justine, you missed out the very important part. I'm just repeating myself again. Okay. Am I audible now?
Okay. Yes, ma'am.
So what I told you, you have to find the distance. That means you have to find the area of this particular thing, right? You can see it look like this, right? It look like this, right? So have you
Yes,
ever,
ma'am.
ma'am, this is rectangle. Tell me, this is rectangle, triangle, square. What is this? Nothing, right? You cannot say, ma'am, this is rectangle. You cannot say this is triangle. You cannot say this is square, right? So basically, this is something very, unique shape. So we will make it something like this. We will divide it. Okay, now you can see this is triangle and this is rectangle. Okay, you're going to divide it. So over here, this was A, this was B. You will keep a point E, and this was T1 and this one's T2, right? So in order to find the area of this unique shape, you are going to add this triangle and this rectangle. So you will get the shape area of this one, right? So in order to find the area of AB, T2, T1, first area of triangle ABE, this one ABE, and area of rectangle AE, T1, T2. Clear?
Yes, ma'am.
So you will write down distance. Distance traveled by between T1 and T2 is area of AB, T2, T1. And this area of this particular thing is divided into two parts. One is area of triangle ABE and area of rectangle AE, T1, T2. Done? Written?
Yes.
Okay. Jocelyn, done? Okay. See, now this is find acceleration and the distance covered by the object between 5 to 15 seconds. So first of all, you have to find the acceleration. Okay. Here I have written 5 to 15. Okay, so you are going to take only 5 and 15. Accordingly, you will first of all, you will find acceleration. You know the formula. Just get the answer, and after that, you have to find the distance. So distance, I will be helping you how you are going to find it out. But first, find acceleration quickly. Done, students? Yes or no?
Yes.
Justine, you also done?
Yes, ma'am.
So it was very easy. You just have to find the this velocity 1 and v1 and v2, right? So it's like 20 and sorry, yeah, it's like 20 and 40, right? So 40 minus 20, it's 20, and 15 minus 5 is 10. So your answer is 2, right? Yes.
Yeah.
Now coming to this, you have to find the distance. That means you have to find the area of this particular thing, right? So of course we will divide it into two parts. One this and other this. So area of triangle AECG and area of rectangle. Sorry, area of rectangle AECD and area of triangle AEB. This one, right? So how you are going to find this? Okay, so for this, see, how you will find the area of AECD first of all. Okay, so area of AECD. So here you can see this one. So this part is still here, right? From here to here. So if you will minus 15 minus 5, right? Out of 15, you will minus this part, right? Which is 5. So you'll minus this. And similarly, coming to here, out of 20, out of 20 here, you have to find this. So till 20, you have to find it like this. So how you will find? Out of 20, you are going to subtract 0, right? Why? Because it is starting from here itself. Okay, just a minute. I'll just explain you. See, students, this is very important. If you will not get this, then it's not possible for you to draw, like find the conclusion. Okay, you have this, right? So this is your triangle and this is your this. For example, this is 10. This is your this is 20 and this is 5. Uh, let's just take this is 5, this is 10 and this is 20. So of course, first of all, you have to find this area of this. So this area means from here to here, right? So 20 is the maximum one and what is the minimum one? This 10, right? So 20 minus 10. And now coming to here, what is the maximum one over here? It is 10, right? Because you are going to find this, right? So it is 10. So 10. And what is the minimum one? 0. Because you are going to take everything over here. So 10 minus 0. Similarly, over here, it was 15. Here you can say it was 15 maximum. And what was the minimum? 5. Yes.
Yes.
Right? So 15 minus 5. Over here, the maximum was 20 because you are going to find this one, right? So maximum was 20 and what was the minimum? Ma'am, 0. Right? So 0. So this is how you are going to find it. 15 minus 5 multiplied by 20 minus 0. So 10 multiplied by 20. So you got the area of AECD. Now coming to this area of triangle AEB. So you know what is the formula of triangle? Half into base into height. Right? So what is your base? Over here, AE is your base. Right? And this BE is your height. So ma'am, what is AE? It's again, now you have to find this. So maximum is 15 and the minimum is 5. So 15 minus 5. Now talking about this, talking about your height, which is EB. So this here, what is maximum? It is 40 and what is minimum? It is 20. So 40 minus 20. So this is your base and this is your height. So you'll just put the formula, put it in formula and you'll get 15 minus 5, 10 and 20, 40 minus 20, 20. So this, you got the 100. Clear?
Yes.
The same.
Yes.
So remember every time whenever you are getting it, for example, whenever you are getting it for any query like this, you just have to check one thing, the minimum, the maximum and the minimum. So over here, for example, it is 10. So this is your maximum point and this is your minimum point, right? So just check maximum and minimum. So first of all, you will write this distance equals to area of triangle, sorry, area of ABCD. Sorry, area of ABCD. Okay, instead of CD, you can even write T1, T2. It's the same thing. Then area of ABCD equals to area of AECD plus area of triangle AEB. Okay, just write this one and then I'll scroll it down. Just write the formula as well and then solve it. Just write this and let me know once you are done. Then I'll scroll it down. Just write the solution as well. Done with this?
Yes.
So just write it down, the solution, and then you can just put the value and you'll get the answer.